All right, so yesterday we did the plate interactions lab. So what I'm going to do is Merrick is going to give us 3 minutes on our timer. So I figured out what happened to my page. There it is. 3 minutes on our timer. And we are going to look at the models that we drew a couple of days ago. We're going to think about that lab that we did yesterday. And we're going to see which of those models of the plate interactions chart do you think best explains what we know about Mount Everest and how it changes. So we did page 56. It was a map with some arrows. Look at your page 56. We have arrows on that map. Okay, so we looked at that plate movement. We drew some arrows, so you know where Mount Everest is located. You're going to look at the plate. It is in the plate below it. And you're going to see what interaction that you think that is. We're going to do that individually. Merrick, give us 3 minutes, friend. That you think took place. Here's your drawings, friend. Yes, it's on Teams. So, you see this right here where it says different plate interactions? So whenever you go on Teams, you're gonna click on that, and they're on there for you. So what I'll do for now, for the sake of this timer, I'm gonna put these up here. So that you can kind of look at them, I know that's kind of small, but you can kind of figure out based off of what we did yesterday. And what we have to do. Yep, that's the one. Type it right there in that top box. Right here. And then we'll walk this forward. You want to give us another minute or so, Merritt? Some of it's still working. guys, Alright, so this plate right here, how did this plate move? If you look on your page 56, how is it moving?
Northeast.
Alright, so it's moving northeast. Good job. If you don't have that, please make that note. This plate here is moving northeast. What about this plate here? How's this plate moving? How is this plate right here moving? What is it? This plate here is moving west? This plate here is moving east. So this is what we have. We have this top plate is moving east. This plate is moving northeast. What's going to happen? Alright, so what are they doing? Are they converging, diverging, transforming? Alright, so we have, oh, here. Alright, so we have a converging. What type of crust are we converging? And then,
Continental.
why do you say that?
Because it shows that the causes that are shown is that it forms mountains and causes the mountains that it forms to grow, and it also causes earthquakes, which we've seen is happening around Mount Everest.
Good job. Alright, so continental. This shows mountains getting taller. And it shows how a mountain can move as the plates move. So convergent, continental. So in this plate in particular, this bottom plate here is moving faster than this plate. So it is moving faster, it's running into it, and what is it making? Making mountains. So if we remember our lab yesterday, it was station 5 over here. Our plates move together, they meet. Then we have our mountain that takes place. If we remember our football players that stood up here, pressed hands, we had this force, we had 2 football players moving together until they didn't. And one buckled, and we had an earthquake. I appreciate your participation, Brent. All right, guys. This next one we are going to skip. So with what we know about convergent, continental, and what we know about Mount Everest, I want you to make a list of the similarities that they have. Merrick's going to give us 6 minutes. I want you to turn and talk. You work with your group and talk about what you know about Mount Everest and what you know about that particular interaction. Go.
So we know that Everest was yeah, it was increasing in height and it was moving convergent. Because it said that the northeast, and it says that it creates mountains. That connects with the convergent area. Because when we were talking about it, coming together. Yeah.
I know that on the Everett that
What we know about Mount Everest. Alright, so what do you know about that interaction? You're going to find that here. And then what do you know about Mount Everest? What have you learned about Mount Everest? How it's moving, growing, what is it doing? What do we know about this interaction?
no.
Change for seniors. You said, did not hear that.
Yeah, you can use that chart and let you know about Mount Everest. Use anything in any of these lessons leading up to this. You have models. You have a model that we drew. Remember that initial model?
Oh yeah, we know that Mount Everest.
Yeah. Sorry, that we go to. That's Mount Mitchell.
Mount Everest grows.
Mount Everest. It grows. You can also
Mount Everest grows.
Y'all working down?
That's not a good one. This one isn't a good one. This might be. For the next page. This one. Open tight one. This one. Wait, is this Mount Mitchell? This one's good too.
Mount Everest is 29,032.
Because we've been talking about Everest.
Mount Everest is 29,032.
You gotta repeat 29,000. Oh, we know there's snow and ice. There's snow and ice in Mount Everest. Yeah.
Is that on all mountains?
What, snow and ice?
Alright, you got about a minute and a half left.
You said you said what?
Ice.
Now, Isabel, we saw our plate interaction yesterday. What happened with the ocean and
Wait, is this the model of what? Is this model of
I think that's Mount Everest. No.
Okay, so now what do we have to do?
I don't think we can read this.
I don't know what
Go back to
this one's too.
I'm listening to progress track because you already put it.
What did we write down?
So we have what we have. It says that it's 29,032 feet above water.
It is. And how's it moving? so it's moving 4 centimeters to the northeast. And what was that plate moving? We have one plate moving east, and how was the other plate moving? North. You see it? Did you see it? Okay.
Alright. Let's come back together. I heard Merrick's timer go off. We're gonna talk about what you guys decided. I'm gonna come back to y'all last and give y'all a chance to write all that down. That was good. That was good. Write it down. Ooh, Tyler. Starting with you, friend. Just give me something that y'all said.
Well, we got to look at Virgin, the two places of places that you got it. So we can count, we can count Mount Everest.
Look here. Say it one more time.
We just very well converging. Places pushing against each other, and we can count Mount Everest over time.
Okay, so the plates push against one another, causing Mount Everest to move over time. And then,
So we said it's on the Eurasian plate, and the African plate is pushing the Eurasian plate northeast.
okay. Cornell. Free to talk up
The
really loud.
Africa is pushing up on
Eurasian. Evan just told us that. You got another one? Okay. Very clear.
We said that the two plates were moving in like a mountain like formation,
Okay.
and so we noticed that. Well, we thought that the two plates would do the same density since one didn't go on top of the other.
Okay, so two plates are the same density. Merrick. Okay. It's what? Bush, okay. Kirsten. What you got, friend?
We said that, so like there's one plate that's moving north, and then there's another plate that's moving east, and Mount Everest is moving 4 centimeters northeast because of the two plates.
Alright, so plates are moving east and northeast, and Mount Everest is moving 4 centimeters. 4 centimeters where? 4 centimeters where? Women. Alright. So could our models help us explain what causes earthquakes? Thumbs up, thumbs down, yes or no? Yes? See some yeses, yes or no? Oh. We all believe so. Do we know what an earthquake is? Let me give you a definition. This is the movement of bedrock caused by plates getting stuck together. And then roughly moving past one another. So now we're thinking like, hey, Ms. Price, that kind of sounds like transform where we saw yesterday of those plates sliding past one another. But if we think about what we just talked about on this convergent, we had one plate moving one way and a faster plate coming up. And we are moving past one another. We are creating this mountain. We are creating a earthquake and whatnot. But then I used a word in here, and we're gonna relate back to it. Anybody see my word? Connor, you're on what I'm on. You're not working on that. Look at this word. All right then. All right, so could our models help us explain what causes earthquakes? We said thumbs up. So now I'm going to give you 3 minutes to turn and talk and tell me how could our models help explain what causes earthquakes. Merrick, 3 minutes, friend. Turn and talk.
Because it helps because it shows the movement of the plate.
Plate formation does the most earthquakes happen.
Is it because it helps because it shows how don't make it hard for me. I don't know what to say. Oh, so I think the models because it shows that they move the that's what I'm saying.
What page are we still on again?
To write the model shows the movement of the plates.
I put it.
So the model shows the movement of the plates.
So you feel like the direction.
I'm putting with this direction. The movement and direction. I don't think we answered that question.
Alright, how could our models, come back together, how could our models help us explain what causes earthquakes? Aiden?
They can help us because, like, for like this one, the conversion of ocean and continental.
Fran, you got a big voice. And whenever you answer this question, you want to talk like this? I need you to talk like this.
They can help us because, like, this mountain right here, the conversion, ocean and continental, the plates are running into each other, and then one of them goes down, so we can see, like, how they.
Yeah, we can. Very clear.
I said that we could look at all of our different models and
Okay.
see which ones cause those earthquakes.
Okay. Good job, Claire.
We heard that the model shows movement of the plates.
Good job.
So we wrote that the model with all the arrows on the plates shows the plates pushing into one another and affecting one another's movement.
Okay. Whenever we did the transform, and I'm gonna use this one just because we saw the visual of it yesterday. When we did the transform boundary at station number 6, what is something that we noticed happened when those plates slid past each other? Mary Claire.
We saw that some of the stuff came off of it.
Okay. Now, Aiden mentioned one of the oceanic continental plates. Now, she just mentioned the edge, and we saw rocks and erosion. We saw things taking place as it was rubbing past. What do you think happens whenever these plates rub past like this? What do you think happens to the bottom and to the top of that plate? Do you think you get maybe the same effect where they're kind of breaking apart in areas? Okay, so now what do we think happens with convergent where they are running into each other, especially like this one? Do we think that they are messing it up each other as they're running across and making these mountains? All right, so on here we're going to put the edges of plates. Some good answers, y'all. Y'all had some good conversations. Alright, so when they stick on a rough spot, and snap out, as we keep pushing. Alright, so once again we saw those transform plates, we slid past, they kind of stick in jagged edges, and then all of a sudden they go smooth, right? Same thing. These converging plates they stick a little bit, and then they start moving the mountain or start making the mountains, and then it's going to be smooth sailing past that, okay? Making those boundaries. What types of plate movement might show this kind of movement? I'm going to give you a moment to turn and talk. 3 minutes, Merritt. Give it to us. What type of plate movement might show this kind of sudden movement? We're looking for a sudden movement. So you're going to tell me, is it convergent, divergent, transform, or all?
It might be all. It might be all. I think it might be all of them. No. Some of these have been it's divergent continental divergent continental. It's convergent continental.
Convergent, divergent, transform.
Convergent.
What do you think, Claire? What do you think would show us this sudden movement, like they're sliding? This kind of sudden movement that we're talking about.
Yeah, that's it.
That's what you said?
I don't know. So you're saying it's conversion? You said conversion? Because the word conversion never transform. I said conversion. I said, which one is the seven movement? Oh, it's on this paper right here. It's like diversion, conversion, or transform. So diversion is when they break up like into separate ways. Conversion is when they make them together. Conversion, but continent to continent. So convergent, you guys agree? Do you agree? So it's convergent. You have to say why. I'm trying to speak to
Alright guys. What types of plate movement might show this type of sudden movement? Claire?
Convergent, continental.
Okay. Connor?
Convergent, continental.
Okay. Aiden?
Convergent, ocean, and continental.
Cornell?
Convergent, ocean.
Okay.
Conversion, continental,
Braylon? Okay. So we have a bunch of convergent and we have a transform. Convergent. Okay. I'm going to say all models could represent a mountain moving laterally. What does that mean? However, convergent is the most accurate representation of how mountains increase in height. Or increase in elevation, since I used that earlier. Increase in elevation. So, Monday, what we are going to do is we are going to update our progress tracker and we are going to prepare ourselves for this CER. Okay? I have a different question than the one that is displayed in your packet. I will give that to you on Monday as we walk through what I am looking for when I grade that CER. So for now, you can quietly pack up, keep out your zone book. Oh, what's today, Friday? SEL, we're doing SEL. So keep out a pencil and your zone book and pack up everything else.